Let us study about factorial. The factorial notation or factorial. The continued product of first n natural numbers is called the n factorial and is denoted by the symbol n factorial, or we can also write like this, which means that the continued product means take natural numbers, first n natural numbers, product of the first n natural numbers, which is nothing but n factorial. So that is given n factorial is equal to 1 into 2 into 3 into and so on. It's a continued product. 1 into 2 into 3 and so on up to n minus 2 into n minus 1 into n. Like an example, what is a 4 factorial? So 4 factorial is a product of first 4 natural numbers, means 1 into 2 into 3 into 4. So which gives the value 4 3s are 12, 12 2s are 24, 24 into 1 24. So this is 4 factorial value. Similarly, if it is 7 factorial, 7 factorial is product of first 7 natural numbers, 1 into 2 into 3 into 4 into 5 into 6 into 7. So we can write here up to 4 numbers we got 24, 24 into 5, so 120, 120 into 6, 720, 720 into 7. So we can consider the answer 5040, right? 5040 is the value of 7 factorial. Means factorial means the product of first n natural numbers, which is given by the symbol n factorial, or also we can also use like this, n factorial. So we can write here 4 factorial, which is equal to 24, or 7 factorial, which is equal to 5040. Okay, and also define that. So we can see a note, 0 factorial is 1. So generally we don't consider the 0 natural numbers. 0 factorial will be defined as 1 because it means that product of first 0 natural numbers. 0 factorial means the product of first 0 natural numbers. That's indicate that is no number we consider natural number. So by default, by generally we can, it is given as 0 factorial is equal to 1. And also we can note down n factorial is equal to n into n minus 1 factorial, or we can write n factorial upon n minus 1 factorial is equal to just a division is equal to n. So let me give an example for this. Suppose, so here we have written 7 factorial. 7 factorial is equal to 1 into 2 into 3 into 4 into 5 into 6 into 7. So if we can see up to 6 natural numbers, the product is nothing but 6 factorial, right? So we can also write this as 7 into 6 factorial. So 1 to 6. So from 1 to 6 is nothing but 6 factorial. This is 7 into 6 factorial. Similarly, if n factorial is given, that can be taken as n into n minus 1 factorial, or also we can use it as depends upon the problem what we required. So we can also write like 7 into 6 into, so you can take only up to 5 natural numbers product, which is equal to 5 factorial. So we can write this is 7 into 6 into 5 factorial also we can write. So depends upon the what is necessary in the problem, we can go ahead and you can solve the problem. And here n factorial upon n minus 1 factorial means cross multiplication. So this problem we can also write like 7 factorial upon 6 factorial is equal to 7. Or even you can also simplify the problem. Suppose, what is the value of 7 factorial upon 5 factorial? So what we can write, 7 factorial we can write it as 7 into 6 into 5 factorial upon 5 factorial, so that we can cancel 5 factorial and 5 factorial. The answer is 7 into 6 42. So this is how the problem will be solved. And third point, factorial of negative integers are not defined. So factorials are defined only for the natural numbers, and also by default it is given 0 factorial is 1. Okay, so factorial of negative integers are not defined. So now let us see some problems based on the factorial. Okay, let's see this example one. Find n if n plus 1 factorial is equal to 12 times of n minus 1 factorial. So let us keep in mind an example by using a second node point. Let me take 6 factorial, which is equal to, we can write it as 6 into the next lower number 5 factorial, or we can also write 6 into 5 into, and the next lower number is 4 factorial. The same manner here n plus 1 and n minus 1 factorials are given, so you need to identify which one is larger and which one is smaller. So clearly n plus 1 is larger number and n minus 1 is a smaller number, right? So here also 6 factorial and 5 factorial. 6 factorial, 6 is the larger number than 5. So 6 factorial can be reduced down to 5 factorial and even to 4 factorial. The same manner n plus 1 factorial we can reduce it to the next lower numbers till n minus 1 factorial. So let us write here n plus 1 factorial, we can write it as the first n plus 1 and reducing to the next lower number, that is n plus 1 minus 1, that is n, and again still reducing to the next lower number, that is n minus 1. So that's required for us, so let us stop it here, n minus 1 factorial. So as per given n plus 1 factorial, that is n plus 1 into n into n minus 1 factorial, which is equal to 12 into n minus 1 factorial. So for n, we can cancel here n minus 1 factorial both the sides, and so that we can write here n into n plus 1 is equal to 12. Clearly 12 is nothing but 3 into 4, since n is a natural number, and so we can consider here n into n plus 1 as 3 into 4 as comparing n is equal to 3, so that n plus 1 is equal to 4. So n is equal to 3 and n plus 1 is equal to 4, so we can just conclude the answer n is equal to 3. Or just by solving this quadratic equation, we will have n square plus n minus 12 equals to 0, so that we can write here n minus 3 into n plus 4, which equals to 0. So we'll have n is equal to 3 or n is equal to minus 4. N is equal to negative integers is not defined as per the note point 3. So we can just conclude our answer n is equal to 3. Okay, right. Let us see another example. Example 2. If 1 upon 6 factorial plus 1 upon 7 factorial is equal to x upon 8 factorial. So we need to find the value of x. So let's use the concept of LCM. So in the denominator on the left side 6 factorial and 7 factorial, on the right side we are having 8 factorial. Since we know that 8 factorial is equal to 8 into 7 into 6 factorial, or we can write 8 into 7 factorial also we can write, right? So here 1 upon 6 factorial, if I can multiply and divide with 8 into 7, 8 into 7 into 8 into 7 into 6 factorial, so multiplying and dividing for our convenience, and here 1 upon 7 factorial, so let's multiply with only 8, 8 into 7 factorial, here also multiplied with 8, so which equals to x upon 8 factorial. So we can write 8 into 7, that is 56, upon 8 into 7 into 6 factorial is 8 factorial, and 8 upon 8 into 7 factorial, which is nothing but again 8 factorial we can write. So this is 8, so which is equal to x upon 8 factorial. Just we are using our normal LCM problems. So 56 plus 8 upon 56 plus 8 upon 8 factorial, so which equals to x upon 8 factorial. So on both the sides the same denominator 8 factorial gets cancelled, so we can write here x is equal to 56 plus 8. So the value of x is 64. Okay, right. Now let us see another example. Example 3. Evaluate n factorial upon n minus r factorial. N factorial upon n minus r factorial when n is equal to 9 and r is equal to 5. So let's use the factorials, which is equal to n is equal to 9, so 9 factorial upon n minus r, that is 9 minus 5 factorial, so which equals to 9 factorial upon 4 factorial. So as I told you before, so first you identify which one is larger and which one is smaller. So 9 factorial is larger and 4 factorial is smaller. and hence we can reduce this 9 factorial in terms of 4 factorial. So it can be reduced. So 9 into 8 into 7 into 6 into, as per our requirement, up to 4 factorial. So we can write up to 4 factorial. So we can write up to here. So that is 9 into 7, 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial. So that we can cancel here 4 factorial and 4 factorial, and let us multiply. 5 6 are 30, 37 are 210, and into 8, so we'll be getting here 1680, and again multiply with 9, so we'll have 54 plus 7 61 and 9 6 15. So we are getting the answer 15,120. So the value of n factorial upon n minus r factorial when n is equal to, so when n is equal to 9 and r is equal to 5, you get the value 15,120. Okay, now let us see another example. Example 4. Find the value of 1 into 1 factorial, 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial, and so on up to n into n factorial. So this sum we can also write it as summation over r is equal to 1 to n r into r factorial. So which equals to, so we can write this as summation r is equal to 1 to n. So let us write r as r plus 1 minus 1 into r factorial. So which equals to summation over r is equal to 1 to n r plus 1 into r factorial minus 1 times of r factorial. So we can also write like this. So now r plus 1 into r factorial, which is nothing but, since we know n factorial, n plus 1 factorial is equal to n plus 1 into n factorial. So an r plus 1 into r factorial, we can write it as n plus 1 factorial. So that is summation r is equal to 1 to n r plus 1 factorial minus r factorial. So now let us apply r is equal to 1, 2, 3 and so on up to n and expand this. So we will get, let us take r is equal to 1 first. 1 plus 1 2 factorial minus 1 factorial plus, when r is equal to 2, 2 plus 1 3 factorial minus 2 factorial plus, when r is equal to 3, 3 plus 1 4 factorial minus 3 factorial, and so on up to, if r is equal to n, so we'll have n plus 1 factorial minus n factorial. So here we can cancel this. 3 factorial gets cancelled, 2 factorial and 2 factorial get cancelled, and 4 factorial will be cancelled with the next number, and so on. N factorial will be cancelled with the before term. So finally it's left with n plus 1 factorial minus 1 factorial. So 1 factorial is nothing but 1. So we can go with an answer summation over 1 into 1 factorial plus 2 into 2 factorial and so on n into n factorial is equal to n plus 1 factorial minus 1. So we can also remember this as a property, summation r is equal to 1 to n r into r factorial is equal to n plus 1 factorial minus 1. Okay, right.